Right. Welcome, everyone. I'm glad that you guys found the room 404. Very hard to find, if you search on the internet, you might not get it. And look at the strength we have anyway. My name is Subodh.
Sorry, keep going.
Keep going. Okay. My name is Subodh. I'm a software developer at Abley, and we develop location-based applications focusing on transportation for farming geospatial applications. So we do a whole lot of things, mainly GIS application area. I'm based in Auckland here. Just bear in mind, English is not my first language. My first language is Hindi. Second is JavaScript, TypeScript. And third one is way down, English. So bear with me if I struggle. All right, enough of jokes. Here's the agenda. What I'm going to briefly talk about: SafeSystem overview. We'll discuss infrastructure components, high level. The problem which we had in our implementation of our infrastructure, with some real code examples. We'll discuss our solution, the library approach we have taken, and we'll discuss convention over configuration, design paradigm, followed by a deep dive on architecture. Not too much in the code, but just overview, and the 3-layer system, some key innovations, some real world example, real code examples from almost from our system, our implementation, and impact and takeaways here. Just a brief intro about Abley SafeSystem. It's a suite of data products that enable road safety professionals, engineers to reduce death and injuries. This specialist data products in the suite of safe curves, safe intersections, and safe roads, namely. Right. I hope you can see the slide. So infrastructure side, we have this stack built on AWS, hosted on AWS, and the solution is served by PostGIS server, PostGIS database, Postgres database, GeoServer with WMS, WFS capabilities, MapLibra for the web application side in the front. But from the back-end infrastructure side, where I normally work, is we use AWS EC2 compute for GeoServer, Nginx containers, and databases also currently in there. Then we have ECS Fargate container service for our AI solution for this system. We are working on authentication service, which might use RDS database. We have S3 standard web assets to serve static website, load balancing, high availability, serving, routing, and CloudFront. And there are a few more things which I might not have listed there. Right. So infrastructure at code. So why it matters? How many of you have experience working in AWS CDK? Oh, that's pretty good. Oh, that's pretty good strength. I think rest of them are still finding room. Right. As some of you have worked on it already, it's defined on AWS Cloud Development Kit code with no click ops, basically. I hate ClickOps. To be honest, I'm really, really lazy. But I believe lazy people innovate more because they can't do work by hand. Version control, you get with this nice infrastructure on a software. You can version control it. It's repeatable. You can configure, you can run it on different environments. That's what we do for develop, testing, and many different environments, which we can spin pretty quickly from it. The code looks like one of the slide in there. So why AWS CDK? Our team is heavy software developers. So we have software developer engineers in the team who, although we work on many different technologies, but nowadays we are working more. Even I was working more in .NET before, but now I'm more in TypeScript, JavaScript. I don't know much about Python though. And we have good TypeScript, JavaScript capabilities within our team. We want programmatic control of our resources. We don't have enough people to do ClickOps. If you want IDE support and type safety, this is a good solution. And it's AWS CDK provides object-oriented abstraction for the AWS resources. So we decided to move with AWS CDK. Before we started with many different approaches. I think it was on Python API as well, CLI, and many different approaches before. But then we said it was too hard to manage, so we started with AWS CDK. So AWS CDK, I could not put Toys beer campaign here, but because of copyright. But assume, just visualize it there on the right side yourself. But yeah, it's actually open source, and there are so many active pull requests at the moment on AWS CDK. The irony is you can only do it with use it with AWS. AWS to host AWS services. You can't do for Azure or Google GCP. You might need to use Terraform or something else. It compiles into CloudFormation template. All right, so we started with migrating our stacks, building our stacks on front-end stack, hosting website stack. Then we started with API stack, database stack, migrating all those into AWS CDK. However, I found that there was so much repetitive code we were writing everywhere, and each stack has copy-paste errors, security inconsistencies, inconsistent naming conventions, resource policy confusion, like some resources have been lying there from long time. We didn't even realize because there was no proper naming convention. It was not easy to group. Sorry, I'll just take some water. The issues with environment detection for dev test, prod, client, demo branches, and there was a lot of technical debt, which we noticed. So what was the solution? So we needed a solution that could handle most things automatically, and it works every time, as long as we use a solution, that solution. So we built this centralized library. It's hosted on our ADO, and it follows the convention over configuration paradigm. I don't know if people here would have worked on Ruby on Rails or .NET MVC framework. It's pretty opinionated, convention-based system. So we chose this convention over configuration paradigm so that everything works. Most of the simple things work by default. We have, you don't have to write a lot of code. You get the right resource policy and all those sort of things with that. And that library sits right between our stacks and the AWS CLI library, which is client library, which is AWS library. So that sits right between us. It has 3 layers, as you notice in this. Base stack, did I spell it wrong? I think. Base stack, base construct, smart constructs, and some utils functions to import across anywhere in these stacks. Behind the scene, it compiles to AWS CloudFormation stack and the resources. Finally, it will deploy the resources, AWS resources. So architecture, just keeping up with the time. Architecture, 3 layers. So it has 3 layers which we worked on. One is the base stack. Base stack, base construct, and smart construct. Examples are listed here, but I'll go little bit more further in the next slides on that. Before migration, we had manual branch detection logic. First of all, that is the branch correct, and it matches. The main thing we wanted to do is from the right branch, it deploy the right infrastructure. So you don't want from develop branch deploying demo infrastructure. That was a problem. So we had that issue. This code was built in every individual stack, right? Repetitive code, and some changes here may not go across the next one. Manual branch detection logic, manual VPC creation lookup, manual security group setup. IP was a main thing. We don't want to expose our develop environment externally. We wanted IP control in there. We wanted some solution which is automatic that handles that part. Plus, there was many 300 lines of code, boilerplate code, which was eventually not needed with this library. Here's one example. I might have jumbled up the pages, the code, but this is just one of the code. There's more lines in this. It keeps on going quite a bit. So this was the before code, and later on something simple after implementing this library. That similar sort of code you can work out in this example. Most things are done by itself, by a single line of code. Right, so as I mentioned that I'm really lazy, so we wanted to innovate a few things. First innovation was dynamic conflict detection. So it should, the code has properties, we know that, context properties in the JSON file or props. We wanted it can work with any property name, any property name, but it should also provide us some sort of warning that, okay, that there's types, this property is not implemented in AWS. So we worked on this. If you look at this code, on the right side, there was, let's say there's maxAG3 configured in the CDK JSON, whereas in the props you have maxAG2. And when you run this code, you might, the library will come up some detection error. Also, if there's a typo in property, if the property is not within the types, it also tells us context only properties detected. 2 minutes only? Oh, that's pretty bad. Yeah. Okay. Innovation 2, context first property model. what we designed is this solution that, priority system, we designed that CDK JSON takes the precedence over the construct props. Props comes second, and if you got this library, the library itself has its own defaults. Benefits, you have configuration over driven infrastructure. Everything is configured in JSON easily. You don't have to do too much in the code with sensible defaults. Innovation 3, branch-based automation. So we had different branches, develop, demo, prod, feature branches, and we wanted proper branching strategy that the resources based on the branch, it automatically implements the IP address. Its policy get destroyed, S3 bucket destroy if the stack get destroyed. Those idea is all built in this library. It can be further improved. Next innovation is the resource policy manager, which I just mentioned. That that's a security feature here. So if you try and implement something wrong, which is not possible, then it will give you warning there that on the main or production level, you don't want to delete your logs bucket. So it will avoid it, and you will get that warning right here. Real world metrics. So we had this code. After implementing this library, the code significantly got reduced. Maybe hyperboling it here, but it was significant level of reduction in the code. We had this base stack implementation, and the main thing is the base stack extends CDK stack, and you can inherit it. It's a level of inheritance which you can use in my stack, for example, here. And what it does, it automatically merges your context from CDK JSON props and look at the branching problem as well. That CDK branch, okay, it will tell you, okay, this is wrong, you're doing right there, and it stops right there. You don't have, it won't deploy. You will get at the synth time, you will receive the error. So it won't deploy anything because it catches before. Sorry, I'm hustling a little bit now. Second level is base construct. Similar design, similar concept. It comes with automatic naming, tagging, because of the context. Context goes look at the tree on the base stack and gets all the naming conventions, tags, context automatically. You don't have to specify that. And the last one is the smart constructs. What is it based on? It's like a level 3 assets, but mainly designed for our convention. And all you have to say is website purpose. This bucket website is purpose. Purpose is website. It automatically will make it public facing, whereas the log bucket is fully private because its purpose is log. So that's the idea around that purpose. And it's configuration driven. So as you see here, there is a dev environment, develop branch, and you can specify your VPC, basic configuration. REST anyway takes care of it. You can override a lot of things here, apart from that security feature, something which I mentioned. But otherwise, you can override anything, but you don't need to because it's convention based. You can specify another branch in there, demo or feature, it will deploy the infrastructure within minutes. Key takeaway, basically it's pretty easy to build your own library. You can deploy it the way you want. Pattern is reusable. The convention over configuration paradigm I discussed. If it works for your organization, you can have your different rules set up. And it's basically context first approach. It merges your context in the properties, and there you go. And And that's the end of the slide. Thank you very much for your time. Sorry I was quite a bit slow initially, but I got through. Thank you.
Great. We have any questions for Subodh? We've got a few minutes.
What is it? Sorry, yeah.
Thanks for your presentation. Just back to your architecture slide before, you had something in there, AI stack. Could you explain what that is and what role it plays?
Yeah, so AI part is the chatbot part within the application, which we have a front-end application. And although I don't know the inside part of it too much, that's a business logic side, but basically speech-to-text detection, and users can search and query the safe roads, safe curves based on whatever filter they want to specify, human-readable AI-based stack.
Okay, thank you.
Yeah, thank you.
Do we have any other questions for Subodh? Must be another question, surely.
I think I was very clear.
I see you're using a CDK JSON. Could it be any other configuration file, like YAML or TOML or something?
Anything.
Right.
And CloudFormation is YAML based, but I don't like it.
Fair enough.
Hey, thank you. Great talk. So the CDK JSON stores environment configs for different stages, for example, dev or staging or production. So do you have one CDK JSON per stage, or do all three stages, are they modeled in that CDK JSON file?
We still have different stacks and their CDK JSON. It's more about one infrastructure, and you can handle different environments. Let's say I want to put a dev infrastructure first and then prod, then you can just migrate it through, put your own config in that CDK JSON, and that will deploy the production instance of it. Is it clear?
I think so. Yeah. I mean, I think, and then do you commit CDK JSON with that configuration to like a Git repo, or is that something that's kind of like a secrets file that you don't pass around? It's only internal.
Okay. No, we do actually push it through to the Git and Git ADO, and the pipeline runs the right config. It has that branch matching logic. It won't let you run if you're running in from the wrong branch, and it only loads that config for that particular branch. Thank you.